Alright. Haven't made a YouTube video in a while, but this stuff's hard, so we're gonna do it. Um, so we're doing sampling distributions, normal calculations, and it's kind of a doozy. So I have the steps here. First, you're gonna label. Well, on the AP test, I would actually make sure it's normal first with my 10 yes, 10 no rule. But first, you're gonna label. Then you're gonna find a z-score. Then you're gonna draw a little picture, and you're gonna use some kind of calculator to find your answer. So let's do this. This will probably take a second, so bear with me. Um, I'm gonna pull up some team stuff here. All right. So we've got the United Kingdom Forestry Commission. I'm gonna label my 4 important things. My little n is my sample size, so that's 400. 47% of the sample, that tells me that's my sample proportion, so that's my p hat. It's 0.47. We've got 3.6 million hectares. That's like the whole thing, so that's my big N. We don't actually care about that. That's the population proportion, though. That's big P. So we've got all the numbers we might possibly need. Labeling is done. Now we're going to find a z-score. I put some formula stuff up here. The old z-score formula was your x minus your mean over standard deviation. We're dealing with sampling distributions now, though. So we're using, so for my mean, we're using big P because the mean of a sampling distribution is big P. So like you see, mean is replaced with big P. I'm going to kind of highlight this. Mean, big P. Your x is usually your value, so this is our sample value. And then the standard deviation right here, you'll notice is the standard deviation of the sampling distribution. I can even make sure I do the blue. So that's kind of where this modified formula comes from. So basically we're just going to plug all our labels into this z-score formula. Bear with me on the handwriting. I'm doing this on the fly on attempt 1. So our p hat was 0.47. Our population p was 0.43. Our standard deviation was, let's see, 0.43, 1 minus 0.43. I'm just plugging my numbers into those variables. Sample size was 400. And I gotta use a calculator for this. So we're gonna just plug this into a calculator really fast. You'll use your graphing calculator. Just be sure you put parentheses around the top if you don't want it to get goofed. Your calculator sucks at PEMDAS. I'm not gonna lie. Actually, it does it too perfectly is really what's going on. So I'm gonna plug this in. Divided by, I'm making sure that it's all, oh gosh dang it. I'm making sure that it's all, is that gonna work? Yeah, I make sure it's all underneath the square root sign. So I got a z-score of whatever the heck, 1.62-ish. Okay, second part's done. It's a different problem. I'm going to draw a little picture of what this question's asking now. So I'm working under the assumption that it's that the sampling distribution for this size sample would be normally distributed. We could check our 10 yes, 10 no rule, but I mean, this is almost half of 400. That's going to be almost 200. So it'll be way more than 10 yeses and then way more than 10 no's. So I can kind of visually see it. We'll work on proving it later. A z-score of 1.62 is somewhere on the right. Remember, because a z-score of 0 is exactly on the mean. So it's just saying our value, our p hat, is 1.62 standard deviations higher than the mean. And then we want to see, they're looking for what's approximate probability that more than 47%. So this is our 47%. the z-score represented that. And so we're looking for more then. So when we plug, this picture just helps us with the calculator. So this is a z-score. And then what your calculator wants you to do is to find boundaries. Your calculator always looks for a lower and then a higher. And then when you put in mean and standard deviation, since we're working with z-scores, you want to put the z-score mean 0 and standard deviation as 1, because 1 z-score is 1 standard deviation. So you always want that. So your lower value is your lowest value in your shaded area. So imagine like a scanner sweeping left to right, like just sound effects. And then as soon as you hit your shaded area, that's your lower, right? And then you keep going, and then as soon as you're done, that's your upper. So your lower, upper. Now, the lower here is going to be 1.62. For your upper, since it goes off into infinity, all you got to do is just put a really high z-score, like 1,000. Now, this will work. You plug this into a calculator, and this will work as long as, you know, it's shaded on the right. Now, if it was shaded on the left, you would want to use like a negative 1,000 as the really far low end. And remember, you're going left to right, so it would the lower always would start at like the negative 1,000 and then go up to where your z-score was. So it looks a little different. The lower and higher kind of swap on if it's on the left side. Anyway, I'll plug this into my Teams calculator. It's the in your stats calculator, you hit second vars. In your TI, you would hit second vars, and then you would hit normal CDF, and then and hit enter, and then it prompts you with a menu, and you could just plug those into your menu. Now, if it doesn't prompt you with a menu, you have an old school calculator. You just type in lower, comma, upper, and you would get it. Now, I'll use this Teams calculator because that's what I have on me. I don't have a online version of a TI-83 or whatever. So I'm going to scroll up, click on the Teams calculator. It actually has everything we need, believe it or not. Normal distribution calculator. Mean we always said was 0, standard deviation was 1. Then we just do lower and upper. So our lower was 1.62. And our upper, we just wanted a really high value, so I set 1,000. And it gives it to you right here. This one that says between 1.62, x is in the middle of 1.62 and 1,000. On your TI, it's just very simple. So we got that shaded area is 0.526. Or sorry, 0.0526. So the answer is actually right up here. The probability that RP hat is bigger than 47% is about 0.05, which is right around what we got. So that's one way of doing it. The more advanced problem comes, I'm not going to do this whole problem, but I'll set it up. The more advanced problem comes when we have stuff like this. This is weird. Let's label really quick. We've got big P. We have big N. And we have a little n. But it doesn't show a p hat. But it's saying, assuming that that this big P is correct, what's the probability that your sample hits within 5 percentage points? So basically what that's asking is, assuming that that really is the mean, what's the probability that your sample lies within within 5 percentage points of that mean? So that would mean like 0.8 and 0.9. I went over this in class as well. To do this, so the shaded area you're looking for, instead of going off into one of the tail distances, you're looking for between those two values. So in this case, you would need to find a z-score for both, meaning you would have to go use the formula for, well, at least one. Sometimes, if they're not symmetrical, you have to use the formula for both. but plug in, you know, so this is one p hat, and then this one is your other p hat. And then when you do finally plug it in your calculator, this will be the lower, and this will be the upper. Now this z-score, you only have to do the formula once because it's symmetrical, so if you find it for 0.9, then you can just do a negative exactly the same for 0.8, and you would be able to find it, your answer in here. And it kind of is giving you a clue about the p-hats just in the problem. I mean, look at that. It's like, oh look, what's the chance that p-hat's between 0.8 and 0.9? So you kind of know you're finding one for both. Anyway, I hope that was helpful. I can make more videos if you need, but I'm just happy to try and help you guys. Hopefully I didn't cover everything up with this corner screen of me, because I'm kind of a disaster. Alright, have a wonderful day, everybody.